Hello, welcome to another Year 11 Maths A tutorial. Today we're going to talk about area, which is the amount of space occupied by a shape. So to give you guys a clear picture of the difference between perimeter and area, I've drawn a shape here and I have filled up the shape with a different color compared to the boundary of the shape. So when we talk about perimeter, as we did in the last lesson, the perimeter is simply the boundary of the shape. Okay, but when we talk about area, area is the space taken up by the shape on the inside of the boundary. So not the perimeter. So that's what area means. And the first shape that we're going to talk about is how to find the area of a square. Now the reason why we're going to talk about it first is because that will lead us on to what units of measure are used for finding the area of shapes. So let's talk about the area of a square. So the formula for finding the area of a square is side times side, which makes it side squared. So imagine if we had a square where each side is 1 centimeter long. Now the area of a square will then become 1 times 1. So 1 centimeter times 1 centimeter, which will be 1 centimeter squared. So really, when we're finding the area of bigger shapes, for example this one, a 5 centimeter square, we're just counting how many little 1 centimeter squares are inside our big square. So for example, with this shape here, it's 5 centimeters on each side. Now if I divide this shape up into 1 centimeter squares, now you can see that I've divided this shape up into little 1 centimeter squares where each square has 1 centimeter on each side. So these little squares have 1 centimeter on each side, so the area of each one is 1 centimeter squared. Right, now how many of these little squares are in there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you counted them all up, it would be 25 of these little squares. Now using the formula of area of a square, we can see that it's side times side, which is 5 times 5, which is 25 centimeters squared. So that saves us a lot of time in compared to counting how many squares there are. Now similar to converting units of measure in when we were talking about length, we can also convert between different units in area. So for example, we have kilometers squared, meters squared, centimeters squared, and millimeters squared. Now if you remember, when we were converting meters squared to centimeters squared, originally for units of length it was times by 100. However, because we're dealing with area, we're now going to double the number of zeros, which makes it times 10,000. Now you might ask, well, why is that? Well, let's use the example. Let's use finding the area of a square as an example. If I have a square that is 1 meter on each side, then the area will be 1 times 1, which will be 1 meter squared. Now 1 meter is equal to 100 centimeters. 1 meter is equal to 100 centimeters. So this same square has an area of 100 centimeters times 100 centimeters, which is 10,000 centimeters squared. So 1 meter squared is the same thing as 10,000 centimeters squared, using the analogy of finding the area of a square. So similarly, if we did the same thing for kilometer squared to meter squared, originally it was times by 1,000 for length, but because we're dealing with area, we're going to double the zeros, which will give us times by 1,000,000. So there's 1 million meter squares in kilometer meter squared. And centimeter squared to millimeter squared, originally it was times 10, but we're going to double the zeros, so it's times 100. And when we're going back up the list, instead of times, we use divide by the same amount. Okay, so using the units of measure conversion ladder, you can try to solve these questions. Okay, so try these questions and come back when you're done. Okay, so 9,000 millimeters squared. We're starting off down the bottom of the ladder, and we want to go to centimeters squared, so we're going upwards, so it's divide by 100. 9,000 divided by 100, cross out 2 zeros, so it's 90 centimeters squared. Now let's do 0.06 meters squared. So we're starting off at meters squared to millimeters squared. So we're going down here. So we're going down 2 rungs on our ladder. So therefore we're gonna times by 10,000 and then times by 100. So how many zeros is that? 1, 2, 3, 4, 5, 6. We're going to move our decimal place to the right by 6 units. So 1, 2, that gives us 6, and then another 4 zeros, so it's 6, 2, 3, 4 millimeters squared. Okay, if you're unsure, you can also just multiply 0.06 by 1 million in the calculator, and that should give you the answer. Okay, now we're going to go down to doing some area calculations with different shapes. So the first one, area of a rectangle is length times width, and the reasoning for that is similar to area of a square. Basically just one side times the other side. So let's say our length is 10 centimeters and our width is 6 centimeters. So the area will be 10 times 6, which is 60 centimeters squared. Now we have just drawn a parallelogram, and a parallelogram has a pair of parallel sides. You can see the top is parallel to the bottom and the left is parallel to the right. Parallel meaning that the lines can extend infinitely and never touch each other. So we have a perpendicular height, which is formed by drawing a straight line between the top and the bottom lines, and this straight line has to be perpendicular to both of these lines. So that's why it's called a perpendicular height. And we have base, which is the length of the base. And the area of a parallelogram is base times perpendicular height. So let's say we have a base of 5 centimeters and a height of 6 centimeters. The area will just be 5 times 6, which is 30 centimeters squared. So you might ask, how come the parallelogram formula is so similar to the rectangle formula for finding the area? Well, because they're essentially the same things. If you imagine cutting out this shape to rearrange it into a rectangle, we can simply cut out this section here and replace this section here over here on the left hand side. Okay, so if we move this section to there, then we pretty much have a rectangle. So that's why the formula for finding the area of a parallelogram is similar to finding the area of a rectangle. And the formula is base times perpendicular height. The perpendicular height will be the width of the rectangle, so that's why they're similar. Now let's do a trapezium. Now a trapezium only has one pair of parallel sides. The other pair of lines do not need to be parallel. So let's say the parallel sides, I'm going to label their lengths as A and B. We also have a perpendicular height, which I'm going to label H. And the area of a trapezium, is just the perpendicular height, or actually let's do half times bracket A plus B times perpendicular height. So you might think, whoa, what happened here? How come it's so complicated? Well, let's compare this shape again to a rectangle. Now a rectangle has also two pairs of sides. So let's say I have the top and the bottom side for a rectangle and the two smaller sides. Now what is the difference between a rectangle and a trapezium? Let's say I have two sides A and B and the height for the rectangle. It's essentially the same thing, except in the trapezium A and B are different lengths, whereas in the rectangle A and B are the same lengths. So this first part of the formula for finding the area of a trapezium, this section here, is basically the average of the top and bottom sides. Right, because all we've done is we've added these two sides together, get the answer, and then divided by 2. So really what we found is what is the average top and bottom length. So then once we find the average, then we've pretty much redrawn the trapezium into a rectangle. And then so once we find the length of the top and the bottom sides, we then multiply it by the height, which will give us the area of a trapezium. So if we do that, if let's say the length of A is 7 centimeters, the length of B is 4 centimeters, and the height is 3 centimeters, so then it'll just be half times 7 plus 4 times 3, which will be 16.5 centimeters squared. Now let's do a triangle. So for a triangle you have also a base length and a perpendicular height. Now the perpendicular height goes up to the tip of the triangle. So once you've decided on a base, basically the perpendicular height is from the opposite angle all the way down to the base, and the line has to form a right angle to the base. So the area of a triangle is base times perpendicular height divided by 2. Now you might say, oh hang on, why are we dividing by 2? Well, if you imagine this as a rectangle, okay, so again we're gonna refer back to a rectangle in this case. If you double the size of this triangle by forming a rectangle, you can see that the rectangle is essentially double the size of the triangle. Right, so we have the perpendicular height on the ends of the triangle, of the rectangle, and the base on the other side as well. So a triangle really is just half of a rectangle. So that's why we use the formula for a rectangle, pretty much base times height, and then we divide it by 2 for a triangle. So that's where the divided by 2 comes from. Okay, so let's say we have the height is 6 centimeters and the base, actually let's use a different number. Let's say height is 7 centimeters and the base is 8 centimeters. So the area will just be 7 times 8 divided by 2, which is 56 divided by 2, which is 28 centimeters squared. Now what if you get given a triangle that doesn't have a perpendicular height given to you? So let's say we have this triangle here, and we have 7 centimeters, 8 centimeters, and 12 centimeters. Now we don't know what the perpendicular height is, and there's no way we can find that unless we draw this actual triangle and we measure it with a ruler, right? Because these lengths are not drawn to scale. Now the trouble with that is, if you want to draw this out on a piece of paper, it'll take quite a bit of fiddling around because you don't know how big these angles are. So the angles aren't even given to you. So what you're gonna do in this case is use another formula, which is called the Herons Formula. So we use the Herons Formula when we don't know the perpendicular height of the triangle. So how do we use the Herons formula? Well, the Herons formula is area equals the square root of S bracket S minus A bracket S minus B bracket S minus C, where S is half A plus B plus C. So you might think, whoa, how did someone come up with this? Well, instead of going into the history of all that, it might be easier for you just to memorize the formula for now. You can probably Google it if you want to find out how this was formed. So basically, the three sides are A, B, and C. You can label them in any order you like. So this one could be A, that one could be C, that one could be B, and so on. And the first thing you're going to do is find out what S is. S is just another variable that we've made up. So the first thing is we're going to go half bracket 8 plus 7 plus 12. And that'll tell us what S equals. So S equals 13.5. And now we're going to do area is square root of 13.5 bracket 13.5 minus 8 bracket 13.5 minus 7 bracket bracket 13.5 minus 12 bracket. And just to remind you, when you see brackets next to each other, it just means times. So 13.5 times 5.5 times 6.5 times 1.5. I've just worked out what was in each bracket individually and then multiply them with each other. Then it becomes square root of 723.9375, which is 26.9 centimeters squared. Okay, so now we're gonna do the area of a circle and sectors. Now for a circle, we have again the radius of the circle, and the area is pi times radius squared. Now I'm just going to explain where this formula comes from. For those of you who are not interested in finding out the reasoning behind formulas, you can skip the next 2 or 3 minutes while I'm explaining. Otherwise, feel free to listen. So where does this formula come from? Well, if you split up this circle into little sectors, so I'm going to cut up this circle into little sectors, and I'm going to arrange them side by side. Okay, so I'm going to arrange each sector side by side like this. So each sector is arranged side by side, like that. And you can imagine the pattern continuing. Now, if I cut them up into infinitely small pieces. Then what happens is the sectors, when lined up against each other, actually becomes a rectangle. Now a rectangle, what is the formula for a rectangle? It is length times width. So rectangle is area is length times width. Now if you arrange all of these little sectors side by side, what is the length of the rectangle? Well, if you remember, the circumference of a circle is 2 pi r. So the circumference is basically made up of the curved sections here and there. Right? So these little curved sections make up the circumference of the circle. Now the length is pretty much half of the circumference. So the length then becomes pi r. Now the width, which is this section here, is pretty much the radius. So therefore length times width is pi r times r, which is pi r squared. So the key to seeing this is to imagine these sectors are really small pieces, and when they line up to each other, they pretty much form a rectangle. So that is the reasoning behind that. And so if we have radius of a circle, let me just draw another circle. So radius is 5 centimeters, then the area will be pi r squared, which is pi times 5 squared, which is 78.5 centimeters squared. Okay, now let's do a final question to do with sectors. Now remember how a sector is really just a full circle. It's just cutting a piece out of a full circle. So this is a full circle. Let's say I have a radius. Now I'm going to cut a sector out of it. The sector will have an angle of theta degrees at the center of the circle. So I'm going to cut out this sector from the circle. And the formula for finding the area of a sector is simply pi r squared, which is the area of the whole circle, multiplied by the percentage of the sector out of, or the fraction of the sector out of the whole circle, which is 360 degrees. So let's say the radius of the sector is 6 centimeters. It'll be pi times 6 squared times, let's say theta is 40 degrees. So it'll be 40 times 360, 40 divided by 360. So typing this in the calculator, remember pi, there's a pi button on the calculator. So pi times 6 times 40 out of 360, and the answer is 12.56 centimeters squared. Rounded, oh, it's 5.7, not 5.6. 5.7 centimeters squared, rounded to 2 dp. Okay, thanks for watching the tutorial on finding the area of shapes. See you again for the next tutorial.